Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk, let's get wrenching.
The structure of the internal combustion engine is known to a wide mass of motorists. But not everyone, knowing what parts are installed in the motor, knows their location and the principle of operation. To fully understand the device of the automobile engine, it is necessary to look at the section of the power unit. The work of the engine in section is presented in this video material engine operation. What to understand the location of the parts of the automobile engine, and before showing the engine in section it is necessary to understand the principle of operation of the motor. So, consider what sets the wheels of the car in motion. Fuel, which is in the gas tank with the help of a fuel pump, is fed to the injectors or carburetor. It is worth noting that the fuel passes such an important stage as a filtering fuel element, which stops impurities and foreign elements that should not get into the combustion chamber. When the accelerator pedal is depressed, the electronic control unit commands the fuel to flow into the intake manifold. For carbureted engines, the accelerator pedal is tied to the carburetor, and the more pressure is applied to the pedal, the more fuel pours into the combustion chamber. Next, air is supplied from the second side, passing through the air filter and throttle. The more the choke opens, the more air will flow directly into the intake manifold where the air-fuel mixture is formed. In the manifold, the air-fuel mixture is divided evenly between the cylinders and flows through the intake valves one by one into the combustion chambers. As the piston moves into the HTM, mixture pressure is created and the spark plug produces a spark that ignites the fuel. From this detonation and explosion, the piston begins to move downward into the NMT. The movement of the piston is transmitted to the connecting rod, which is attached to the crankshaft and drives the crankshaft. So does each piston. The faster the pistons move, the higher the crankshaft RPM. After the air-fuel mixture has burned, the exhaust valve opens, which releases the exhaust gases into the exhaust manifold and then through the exhaust system to the outside. On modern cars, some of the exhaust gases help the engine's performance because it drives a turbocharger, which increases the power of the internal combustion engine. Also, it is worth noting that on modern engines cannot do without a cooling system, the liquid of which circulates through the cooling jacket and under the hood, then provides a constant operating temperature. Engine in section. Now you can consider how the internal combustion engine looks in section. For greater clarity, let's consider the VAZ engine in section, with which most motorists are familiar. The diagram shows the VAZ 2121 engine in a longitudinal section. 1. Crankshaft. 2. Crankshaft main bearing shell. 3. Crankshaft sprocket. 4. Crankshaft front oil seal. 5. Crankshaft pulley. 6. Ratchet. 7. Timing cover. 8. Coolant pump and alternator drive belt. 9. Alternator pulley. 10. Sprocket drive oil pump, fuel pump, and ignition distributor. 11. Roller drive oil pump, fuel pump, and ignition distributor. 12. Cooling system fan. 13. Cylinder block. 14. Cylinder head. 15. Timing chain. 16. Camshaft sprocket. 17. Exhaust valve. 18. Inlet valve. 19. Bearing housing camshaft. 20. Distributor shaft. 21. Valve actuator lever. 22. Cylinder head cover. 23. Coolant temperature gauge sensor. 24. Spark plug. 25. Piston. 26. Piston pin. 27. Crankshaft rear oil seal holder, 28. Crankshaft retaining ring, 29. Flywheel, 30. Upper compression ring, 31. Lower compression ring, 32. Oil ring, 33. Clutch crankcase front cover, 34. Oil sump, 35. Front support of the power unit, 36. Connecting rod, 37. Front support bracket, 38. Power unit, 39. Rear support of the power unit. In addition to the inline arrangement of engine cylinders, as shown in the diagram above, there are internal combustion engines with V and W-shaped arrangement of the piston mechanism. Consider the W-shaped motor in section on the example of Audi power unit. The cylinders of the internal combustion engine are arranged in such a way that if you look at the motor from the front, the English letter W is formed. These engines have increased power and are used in sports cars. This system was proposed by the Japanese manufacturer Subaru, but due to high fuel consumption it was not widely and massively used. V and W-shaped internal combustion engines have increased power and torque, which makes them sports-oriented. The only disadvantage of such a design is that such power units consume a significant amount of fuel. With the development of the automobile industry, General Motors offered a system of disabling half of the cylinders. Thus, these inoperative cylinders are actuated only when it is necessary to increase power or quickly accelerate the car. This system allowed for significant fuel savings in the everyday use of the vehicle. This function is tied to the electronic engine control unit, because it regulates when it is necessary to engage all cylinders, and when they are not needed. In conclusion, understanding the schematic section of an internal combustion engine is essential for grasping how these complex machines operate. By breaking down the various components and their functions, we can appreciate the intricate design that allows for efficient energy conversion. Whether you are a student, a mechanic, or simply an enthusiast, this knowledge enhances your ability to engage with automotive technology. Thank you for watching, and we hope this exploration has deepened your understanding of internal combustion engines.